Hi, everybody. Welcome back to the Astro Imaging channel for this Sunday. Hope everybody is doing fine out there. It was a nice warm day in Southern California, and I'm sure it's nice every place right now. I hope for those of you where it's dark, you've got your imaging rigs out there running. Tonight, Alex Cherney is going to join us. Now, we've had presentations in the past about nightscape imaging. We all love to take nightscape images with the sea and the stars and things like that. He's going to tell us a little bit about how he does it, and then he's going to tell us about time-lapse photography adding to that. And so he's going to have a very special show for us. But I want to tell you about my week. My week was really special because on Wednesday, I sat down with our Facebook page, our Facebook group page. And if you haven't been to our Facebook group page, you can find that there's a really cool place to add all the images you're taking and contribute to the Astro Imaging channel. So that's really cool. Anyway, we ask that you put your NeoWise pictures up on the Facebook page, Facebook group page there, and a lot of you did. I think we got something like 38 pictures. And so we put it together. And Molly has a slideshow that she'd like to show you. And Molly, I'm going to turn it over to you. You take over, okay?
All righty, let me go ahead and hit play on this. think I missed the ending of it there. Yeah, carry on.
Is it over?
I think so.
Yes, I think
Got a
so.
ways.
You'll tell me when to start casting, right?
YouTube's about 30 seconds behind, so.
Right. You'll let me know when to begin casting.
Well, if that was Alex, we've still got 2 or 3 minutes after the show.
Okay. Okay. Yeah, then you do the introduction, and then I'll take over, right?
Yeah, right.
Yeah, sorry. I might have ended the video early, so apologies.
Okay.
We'll press forward.
Hi, everybody. I'm back. And I think we still had a little bit of stuff to go on that video. Maybe we can just put that video up at some
Yeah,
point
I can put the video up. Yeah.
as a separate video. I
Yeah.
want to thank everybody who contributes. There are probably 25 different authors or different photographers going in that pile, and maybe 38, I think it was, different pictures, and the music was generic. Because it was easier with copyright laws and stuff. And that's the first time we've done that. And if you like us doing that, well, then I would suggest that we maybe do it again sometime. We maybe pick a constellation or a target or something like that, and we focus on that for the night. Anyway, you should be seeing my screen right now, my YouTube screen. And over here on the right hand side, there's a place for you to put all your comments, and we hope that you do that. We got 49 people watching right now, and there's some places for you to donate to the Astro Imaging channel. There's some places you can check here, you can check over here. We're up to 9.27 thousand subscribers. We hope that you continue to support us by subscribing to us. Just click the button, and Alex is going to put on a good show, so go ahead and click the like button when you see that. And I think, why are we there? Why were we okay, there we go. So anyway, it's time to talk about Alex now. Alex Cherney is coming to us from Melbourne, Australia, where the constellations are all upside down. And he lives in Melbourne. He's an IT consultant. He got hooked up with astronomy after helping his kindergarten kid working on an astronomy project back in 2007. And he just kind of took it up and got more and more into it. He likes showing all sorts of different things, combining nature, the land, terrestrial stuff with the sky. I'm not going to take up too much more of his time. I'm going to turn it over to him. Go ahead and take over, Alex. Take over. Tell us what you have to tell us about nightscapes and time-lapse photography.
Hello, everyone, and thanks, Alex, and everyone at the Astro Imaging channel for inviting me to do this show. It's really great to be presenting today. So hopefully my screen is coming through with the first slide of the presentation.
You're good. You're good.
And yep, so today I'll talk about my journey in astronomy, how it started, where it took me, and share some of the techniques that I use when I create those time-lapse animations, and they are hopefully simple enough that can be followed. So it all started for me when my daughter, she is now finishing school next year. She was then in and 4-year-old kindergarten. Came back home with a cardboard rocket on Friday and said, "Daddy, can you help me find aliens?" And being a reasonable parent, how can you say no to such request? So we started looking online, and I was really, really fortunate to find a local astronomy club nearby, Mornington Peninsula Astronomical Society. We went there, looked through a number of large telescopes. That was the first telescope I looked through, an 18-inch Dobsonian custom built by Greg Walton, member of MPAS, and that was early 2008. I think we saw rings of Saturn and Orion Nebula, and it was an eye-opening moment. I knew I was hooked in for a long time with this, so we discussed it at home, and in pursuit of the aliens, the first telescope was purchased, the 8-inch Dob. That lasted 6 months, I think. or thereabouts, and was upgraded to a 12-inch Dobsonian to look out further and hopefully find them quicker. That lasted another year or so, and the aperture fever has set in well and truly by then. I've upgraded to a 22-inch custom-built truss Dobsonian that I can pack in the car and take everywhere with me, and it's still nothing bigger would fit in the car without a trailer. So I think I'm content with the size of this telescope, and I had everything planned out for the next 5 years to observe until in 2011 I had a chance to look through this guy. That's a largest single mirror optical telescope on the planet, Gran Telescopio Canaria on La Palma. And how I got there was through this kind of very simple, non-technically advanced, the astro imaging on a tripod. So the first shot I ever took was in Border Stargaze, gathering of amateur astronomers in August 2009, when I borrowed a tripod from Greg and put my Nikon D700 DSLR on that tripod. I had an ultra-wide-angle lens, Nikon 14-24 millimeters, and took that shot, 30-second exposure, 6400 ISO, pressed the shutter button, and must have bumped the tripod in the throughout the exposure. But at the time when I looked at the back of the screen, I thought, wow, first shot, meteor shower, how lucky am I? Later, obviously, it became obvious that those streaks are next to locations of bright objects, bright stars and planets, and it must have been a bump. But nonetheless, that was something that ignited my interest, because I could see the color in the Milky Way that you can't see with your eyes. You could study the structures a little bit better. And then I started thinking, what else can I do with it? Why not leave the camera running all the time, taking one shot after another, and then animate it on this in computer software, create a time lapse. So that was early, sort of in 2010, and that started a travel spree around Victoria with my family, and that travel had to happen around the new moon, obviously, to facilitate the imaging. And I shot this time lapse over multiple nights, 6 nights, along the southern ocean coast in Victoria. So I'll play that time lapse. I'll cast it to the channel. And let me know when that's coming through. I'll start playing. I guess it should be good now.
We're seeing a blank. There we go.
Yeah, so that's the Milky Way setting into the Southern Ocean, not far from Melbourne. That's at Cape Schenck. The clouds, when they appear and don't obstruct the whole sky, they add another dimension to the time lapse. So they're continuous 30-second shots taken one after another, and then animated at roughly 25 frames a second. So those lights on the water, they're ships coming in and out of Port Phillip Bay. So that's what the sky looks like in sort of late September, early October for us. There you can see 2 Magellanic clouds, the Emu rising on the left, and that bright green light, it's a squid boat attracting octopus with bright lights. And the moon will be rising in the left. And that is one of the iconic locations on Victorian southern coast. It's called the Great Ocean Road. The place is 12 Apostles. The lights behind the Apostles are from a small town called Port Campbell. And sort of I really liked how the waves animated faster in the time lapse work together with the sky, and then gives you creative room to add some music that kind of captures both motions. That Jupiter setting creates really nice light path on the water. Again, in time lapse, it's much nicer than it is in still images. So it prompted me to go more and more out and shoot. Weather on Great Ocean Road at 12 Apostles is really, really difficult to get. I was lucky to get 2 clear nights. So that's the second night where I've turned the camera 180 degrees out to the other side. And you've got Orion rising upside down for Northern Hemisphere dwellers, and Carina as well out there, great Eta Carina Nebula. So I sort of put that time lapse together and submitted it to the Stamos astrophotography competition, which was held in Tenerife on Canary Islands, and was really surprised when got an email saying that the time lapse was selected as the overall winner, and the prize for that was a trip to Canary Islands, 1 hour on that Gran Telescopio Canaria, on that big telescope, to image an object of my choice, and that was the object that I selected, the pair of interacting galaxies ARP-84. So I think that image is a combination of 15-second exposures. Anything brighter would saturate the detector. And it's shot through not the RGB, the other filter model. So it's actually sort of synthesized to look more or less like RGB. The star colors are almost correct. And Noel Carboni helped me with processing of that image. It was really good fun to actually see how the telescope operates. I spent the whole night in the control room, and then I went around and shot the telescopes in the observatory. I'll play that time lapse as well. But if that wasn't enough, the second part of the event was the kind of science music festival with all these people that you see on screen that I was able to talk to and see the firsthand. So that was the highlight of 2012, and really I think helped me keep going in this. I often go back in memories to those days, and whenever I do a presentation like this, I really like talking about it, because it sort of takes me back in the time machine to that event, which was beyond awesome. So let me play the time lapse with the telescopes out there. Full screen. Sorry, I need to cast that. So hopefully that's coming across, and I'll start playing. That's the grunty at the sunset. Those 2 cars are RAV4s, so that gives you a sense of scale and perspective. A bit of zodiacal light and the clouds running underneath the telescope. The observatory is at 2,400 meters. So that's looking towards the northern sky. Oops, sorry. Strong green air glow as well. And then I walked around the observatory. I didn't have a car with me then, so it was physically demanding, but worth it. And those Cherenkov light detectors, they were out of operation because of the upgrades of the computer equipment that was happening. So I was able to set my camera next to them and take shots. My panning device ran out of power about now, and just accidentally I was able to turn it into something really positive with the star trails running across the sky and across the dish. The dish is 40 meters in diameter, weighs enormous amount of ton, I think 36, and can rotate to any point in the sky in 40 seconds. So they get a signal from one of the satellites and have to follow up the gamma ray bursts and try to detect Cherenkov radiation. So that was that trip down the memory lane to 2011, when, yeah, I guess highlight of my nightscape photography, really. So let's now we move into part of the presentation where I just describe the way I do it and what you need to take those images with the DSLR and a tripod. Almost everyone has a DSLR or a mirrorless camera, and even a kit lens that comes with it allows you to experiment with those nightscapes. And the best place to start, if you're observing out with a telescope, set it nearby on the tripod and capture that process of how you look, how you observe with the scope, or how you image with it, and then it can yield some interesting results. So first, I always start with appropriate clothing, and it is applicable across the globe. Even in Australia, it gets really cold at night. Even in summer, it can drop to below zero. And if you're stationary standing next to your tripod, it can get cold really quickly. So appropriate clothing cannot be overestimated. A sturdy tripod that will hold your camera comfortably and withstand some wind. A DSLR or a mirrorless camera, and I keep saying that the brand of the camera doesn't really matter. All of the manufacturers nowadays produce cameras that are capable of taking excellent images at nighttime with low noise. Wide-angle lens, 18mm kit lens is a good start. Wider the better. Two reasons for it, and one is that it will take more of the sky, and the second is it will allow you to expose for longer, and we'll get back to that in the next slide. Remote trigger. Most of the cameras now have intervalometers built in. Some don't, and if they don't, then a device like that pictured at the bottom is inexpensive and can be purchased on eBay for $20 or less. And a torch or headlamp, red light, but you know that. So for time-lapse, when you're taking one shot, what you had before is sufficient. For time-lapse, you need to think about more items, which is external power, if you want to go more than the built-in battery allows. And from my experience, you can get somewhere around 3-4 hours on a built-in battery in Canon 6D or Nikon D700. If you want to go longer than 4 hours, 3-4 hours, then you can either use a grip or use external power from an external battery. You need larger SD cards to store the images. 128 gig SD card is capable of holding multiple nights of images on Canon 6D. If you're shooting with Nikon D850 with enormously large 40 megapixel files, then it would still hold one night. And one thing we need to worry about here in Victoria is dew, condensation. You need to keep your lens, like your lens of your telescope, slightly above ambient. And I use telescope dew heaters wrapped around the lens for that purpose. If I don't have them, then a quick sort of solution to overcome that are those chemical hand warmers that are sold in the outdoor shops. And I just tape a pair of those around the lens with the electrical tape, and that keeps the lens warmer for about 11-12 hours. Only works in ambient temperatures above 0 Celsius. If it drops below 0 Celsius, they stop being effective. And I found that out in New Zealand. And a bubble level, again, some cameras have those bubble levels built in, but I prefer to have a 3-axis physical spirit level, which is around $2 or $3 on eBay as well. So what settings do you need? We want to keep the camera in manual mode. It needs to, because we don't want the camera to guess the exposure. We don't want the camera to autofocus for us. We'll do it manually. We want manual white balance around 4000 Kelvin. The reason for that number 4000 Kelvin is that at that white balance, the color of the Milky Way is closest to its natural form, which is pale yellow. So if you shoot at too warmer white balance, say 5000 Kelvin, sunny, or even warmer, it'll become too red, and at cooler white balance, it becomes too blue. And I've seen, unfortunately, a number of examples where people, for artistic purposes, change the color of the night sky. And I think that alters the expectations of the viewer because they are not capable of correlating that to a color of a sunset. So if you made sunset green, and show that people would immediately know that it had been changed. But with the night sky, city dwellers don't know what it looks like. Our night vision is not sensitive to color, and I think it's our we need to try to present the night sky in the most realistic way possible, and that is around 4000 Kelvin. If your camera doesn't have Kelvin setting, just set it to sunny, which is 5000 Kelvin. It's close enough. And if you shoot in RAW, then you can always adjust that in when you open the RAW files. So that was about the colors of the night sky. ISO 3200, 6400, somewhere thereabouts, 15 to 30 second exposure length, and that's assuming that there is no moon or very little moon in the sky. You would want to have your lens, if it's a zoom lens, at widest possible setting to get as much of the sky as possible, and largest possible aperture, smallest f-stop. Kit lenses come at f3.5. At that aperture, usually the corners, stars in the corners look elongated. They don't look right because of the optical aberrations, coma, namely, and astigmatism. And what I do with kit lenses, or advise to do with kit lenses, is stop them slightly to f4. That reduces the aperture and removes those optical aberrations to a degree. But the best for that type of photography is a wide-angle prime lens, which, let's say, 30 millimeters f1.4 or 14 millimeters f2.8. So the brighter, the better. And how do we focus? With digital cameras, it's really, really easy. You set the camera to manual focus, so all the hard work is not undone when you try to trigger the exposure. Then set the focusing ring close to the infinity mark. If there is no infinity mark on the camera, then sort of furthest away from closed focus. You find a bright star, a planet, the moon, and center your camera on it. Magnify live view to as far as it goes, and then rotate the focusing ring back and forth until you get the smallest star image. And usually at that same point in time, smaller stars also pop out into existence because they're focused. If your camera and lens, the lens is very dim and the camera doesn't show any stars at night, and I've seen that happen with, say, APS Canon cameras and kit lenses, what you can do is you can focus on the clouds. You can, during daytime, you can focus on a distant mountain or distant object in the daytime, and that will be close enough. And then you can just wrap electric tape around your lens to make sure that focus stays in place. How long can you expose for? The wider your lens, the longer the possible exposure. And when I say longer possible exposure, I mean that the star trailing will not be evident in the images. There is kind of a rule of thumb, which is called the 600 rule, where you take the 600 number divided by the effective focal length of your lens for the full frame sensor. So, for example, you're shooting with Nikon D5100, which is 1.5 times crop APS sensor, which is smaller than the full frame. So you multiply 18 by 1.5, it's 27, divide 600 by 27, and that number comes at 22 seconds. But that also depends on where are you shooting, where you're pointing in the sky. If you're pointing towards celestial north or celestial south, where stars rotate the least, or draw the smallest circles, then as you can see in this image on the left, they're parts of the same frame at the bottom. One is taken, so the image was taken with 14 millimeter lens, 30-second exposure. If you look at the southern celestial pole near Octans, the stars are nice and round. In the same exposure, looking towards celestial equator near Scorpius, that bright orange star is Antares. You already see that the stars draw small, shorter lines. How long these star trails can go, it solely depends on the output. If you're shooting for time-lapse, it doesn't really matter. There's little, as long as it's not kind of excessive. If you're printing to A3, that wouldn't show up as lines. Anything bigger would be problematic. But for time-lapse, that kind of rule of thumb, 600 rule, works quite well. A note on long exposure noise reduction, which is normally turned on by default in all of the cameras, which is taking a dark frame for you and subtracting it from your image, which is good for stills. But if you're running time-lapse, you don't want to spend another 30 seconds waiting for the dark frame to be taken. And slow down your time-lapse, give you less frames as the output. And also create gaps, sort of the motion will be jerky. If you're wanting to do start rails as well, then there will be gaps in it. So long exposure noise reduction needs to be turned off before you're shooting time-lapse. And which way to shoot, RAW or JPEG? I think with the cost of SD cards now, it's almost a no-brainer answer that RAW capture is preferred. You're not converting and throwing away data in camera. You can extract a lot more from it by applying different contrast curves to your image when you process it, and we'll look at it in a moment. Noise reduction is usually, you can't turn it off completely. It's still applied by the camera, and white balance is applied and baked in to the JPEG image. So all of these things that you can fix and change and extract more information become unavailable in JPEG. Therefore, I always shoot RAW. If you want to have those images immediately, you can shoot both RAW and JPEG together. So that's kind of a technical part. And if you have any questions about that, maybe I can answer them at the end of the presentation. I think let's go through the planning and framing, and then processing. And in the processing of time-lapse, some of those will be answered by what I'm doing, and then I'm happy to take Q&A later on. So planning and framing for time-lapse and for any nightscapes is as important as planning and framing your deep space image for impact, for artistic impact, for what you want to say with your image. And these are my subjective views, just based on what I like. So it's not universally applicable to everyone, but finding that what you like and trying to show it in those time-lapse animations in motion is, I think, would always make it more interesting for others to look at. So where we begin is, where I begin usually, is with looking at what's happening in the sky, where there is something interesting, a comet, alignment of planets, moon, something that would attract attention, something that I want to shoot. And so in this example, you see the bottom shot from Stellarium, the computer planetarium software, where you can set the field of view and sort of plan for the shoot. So the field of view in Nightscapes is limited, or not limited, by the lens you're using. So in this case, I wanted to shoot an alignment of Pleiades, Moon, planets, and Orion early in the morning, and to show the Moon in anything else other than a bright spot, I wanted to use a 30mm lens, so the Moon would be somewhat detailed, recognizable as the Moon. So when you put the 35mm lens into field of view calculator, and that there is one available, plenty of them available online. The one I was using at that time was field of view calculator at the link on the screen. Tells me the field of view is 54 by 38 degrees, and in Stellarium I would select a 3x2 frame with those dimensions in the degrees, and you can use angle measure to confirm that. Frame it, see, yep, the 35mm lens does exactly what I want, shows that part of the sky. Now let's find the landscape. That conjunction alignment happened to be when the Central West Astronomical Society Astrofest was on near Parkes, and I'd be there. So Parkes 64-meter radio telescope dish is an obvious choice for your object in the foreground. So then I'd plan where I need to be on Google Maps to be looking at that specific azimuth, and the end result was this image with the Moon, Pleiades, Orion, and Jupiter and Venus in the frame. So that sort of planning, that didn't turn out to be a time-lapse because we only had, you can see the clouds above and clouds coming in. There was a opening of maybe less than 3 minutes to take that shot. So for planning Stellarium on the computer, there are a number of mobile apps that allow you to do similar thing, but I prefer to use Stellarium and another tool, Photo Ephemeris. There is an app for the phone and a free application for your Mac or PC. Runs in the browser and shows you the path of the moon, the sun, and you can plan the shoot accordingly if the moon is in the frame. So let's go to framing. So that goes back to what you want to highlight in the landscape, what you want to highlight in the sky. Whenever I travel and find something, a landscape that is interesting and is away from light pollution, I would take a shot of that landscape and put it on Google Maps in as a favorite, and also photograph the compass, so I know exactly which direction am I looking at. And whenever there is something interesting in the sky, like that alignment or a comet, then I would go through that database and find out where I can go to take that shot, and then look at the weather and decide which one I want to go to. So this was the crescent moon, 10% illuminated. Came out quite bright in a 15-second exposure, but it didn't overshine the Milky Way despite being close to it. So that was, you would have seen that as an opening sequence in that first time lapse that I played. Putting images in context. So this is typically Australian scene with signs warning about kangaroos in the next 4 kilometers. When I saw that, I had to stop and put the tripod in the middle of the road, hoping that trucks don't interfere with my photo session. But it's a straight road, so you're kind of safe. You've got 2-3 minutes before it's too late. So that's kind of typical Australian nightscape. If you take those kangaroos away, that could have been shot anywhere in the southern hemisphere. It doesn't tell much. So I tend to include something that's descriptive of the place where I'm at as well, if possible. So this was also in the opening time lapse, that scene. When I was setting up, I knew the moon would cross that sort of little feature on the rock that I liked during the evening time when I was scouting the location. And you set up a time lapse, you hope that it will work, and there will be a moon path on the water highlighting that feature, which then a frame from the time lapse becomes a still image, and you can pick kind of the best one. So instead of when I do my nightscape shooting, I would usually set 1 or 2 cameras up for time lapse in different orientations, sort of looking at different parts of the sky and the landscape, and then I would use a 3rd camera to do stills. And then you go through all of the footage, and more often than not, you pick up something really cool, really interesting. It's like fishing. That's, I guess, what keeps me doing that. This image from Lake Takapo, New Zealand, South Island, was first night we arrived on the island with the family for a holiday. And I sort of saw a little opening in the sky. I thought, oh, well, let's set up and hope for the best. And it worked out really well with those rocks. So again, in that case, I was planning to have the rocks and the core of the Milky Way aligned at the right time. And with Stellarium, you can fast forward in time and kind of get your bearings and set up for to show that scene in motion. Or this one, that's a similar alignment to what you saw with the dish. That's a church of the Good Shepherd with Pleiades, Jupiter and Venus, and then Orion above the church. So I was trying to get that right, and then the fog nearly stuffed it up. So I'll play that time lapse from New Zealand just briefly. Let me cast the tab. So that is the that's the cloud dissipating right in time.
Alex, you're not casting right now? You're not sharing?
Let me go back to it. Cast. Is it coming across now?
Yes, it is.
Okay, sorry about that. So that's the cloud disappearing. And the core of the Milky Way setting. Magical place, South Island. Really, really dark and with great transparency. And when you get the weather, it's words can't describe it. So that's an artificial lake, Lake Takapo, which is fed by a glacier. So that's the where that glacier water comes in. It's very shallow, and I was trying to get the reflections in the water in the ice. Beautiful mountains with snowy peaks, and then the core of the Milky Way was planned to be setting in the gap after the mountain, hopefully with some reflections if the water is still enough. One of those occasions when the calculations worked, and it was right on schedule. So these lights in the front, you see the light of the Lake Takapo village. So that was all night from sunset to sunrise, nearly about 14 hours, a really long night. So let me skip that a little bit to interesting bits where we've got light of the Lake Takapo village. Underneath the clouds. That's on top of Mount John, about 700 meters above sea level, 400 meters above the village. With the southern sky. Looked really cool in person as well. I couldn't stop admiring it. It wasn't moving as quickly, but still very, very sort of eerie. Still Great Carina Nebula in the sky, you can see, coming into the frame. So they're all 30-second shots, as small gap as possible. And that's 14mm lens looking towards the Church of Good Shepherd from the other side. So that camera was running there. You can see fog coming in, and with the second camera I was trying to get that alignment of planet and Orion from the other side. So that'll be the ending sequence in this time lapse. And by the way, all of these time lapses are available on YouTube. If you put Alex Cherney in, you'll see them. That's a main observatory of New Zealand on Mount John at Lake Takapo. That's a 1.1 meter telescope. So that's the church I'm setting up, hoping for those planets to rise, and suddenly the fog comes in and blankets everything. I thought, oh well, that's all gone, too bad, but the camera kept running. And the fog lifted just at the right moment, providing that superb atmosphere to the time lapse, and that's still shot. So that's, let me pause that. So that's a time lapse there. Let's go back to the presentation. So what I wanted to do now is take you through a quick practice session. How would you go about creating those animated sequences without any extra tools? I assume most of you have and use Photoshop, and that's why I've chose that as a tool of choice for this presentation. And what we do first, the first step is to open your raw files that you shot in a sequence, and say you're animating at 25 frames a second. To make a 10-second sequence, you need at least 250 shots. So that's 125 minutes. It's about 2 hours and a bit of real-time shooting. That's the minimum. That gives you 10 seconds. If you shoot all night, obviously it becomes longer. So what we do is we go in, open Adobe Bridge, which comes together with the Photoshop and all of the Adobe Creative Cloud. And let's just do that. So go into Bridge, navigate to the folder. I prefer to work in film strip mode for it, but you can choose another, it doesn't really matter. So you select all files with Control A and right click and do Open in Camera Raw. But let me share the screen rather than the whole of my screen rather than a stop casting. Separate tab. Share screen. So that should be coming across. So that's the slide, and let's go to the live program. So open the folder, select a file, select all of them, right click, and then go open with Camera Raw. So that opens a set of files in in Adobe Camera Raw in Film Strip. So you see all of them there. I've edited the first one already, but let's pick a frame that was shot on Mornington Peninsula, not far from where I live. And there was kind of a faint aurora. You can see that happening around there. So let's pick one where there is some activity there. I think it was a bit later in the sequence. Yep, here. So that's a unprocessed image shot with 30-second exposure. Let's do the magnifier. So 30-second exposure, ISO 3200 with white balance of 3800, and it's set as neutral as possible. So you see it doesn't look very exciting, and we want to process it a little, and I show you a few quick processing steps. Why we're doing it in Bridge, the reason for it is that you process one image and then you can apply all of these settings to all of the other images in Adobe Bridge, and all of them will look the same. So let's bring this image to life a little bit, and then again, this is just the way I tend to process images. There is no golden rule about it. One thing is that keeping the night sky realistic is key, I think. And then you have your artistic license to work a little bit with landscape, a little bit with the sky to increase the contrast, but still keeping it real. So the first thing I usually do with my images is adjust the white balance, pick up an area of the sky that should be neutral gray. Not always possible. In this case, that should be somewhere in the corner there. So I click on the eyedropper on the white balance tool on this guy here, and then click anywhere in the image where it should be gray. That's a bit too green. Yeah, that's about right. And that produced, let's go there, yep, 3950, around 4,000 Kelvin. So not much change from what I had set it. But if you didn't set the white balance right to begin with, then you can always do it in post-production in Adobe Camera Raw or your raw processing tool of choice. And what I'm showing here is easily translatable to other raw processing tools that you might use. So then we want to make it a little brighter, increase the exposure, and don't pay too much attention to those values, exposure plus 0.7. The key here is to make the scene look like you want without blowing out highlights and losing information, or without plunging the landscape to darkness. So we go plus 0.7 on the exposure, maybe a little bit contrast of the overall scene, at the same time lifting shadows a little bit, and you notice that it only affects the bottom part, the landscape. So need to be careful with lifting shadows too high. It can create some artifacts. So in this case, maybe around 45. And be your eyes the best judge of how does it look compared to the original and compared to what you've seen when you were shooting it. Then we might want to add a bit of saturation to the image. When I shoot, I set the camera profile to neutral, so it's everything at 0. Doesn't boost contrast, doesn't boost saturation. So as the first step of processing, that's good. Then what I would do in addition to that is go in and process top and bottom parts of the image with graduated filters slightly differently. So I would select the graduated filter, put a filter on, and if you hold Shift button on Windows, then it will always be straight. It won't tilt. So what happens now is it will apply, let's just play with it. It will apply changes only to the top part of the image. It's not what we want to do with it. We want to increase contrast more for the sky, maybe lift a little bit exposure, just a bit, 0.2. And try and play with dehaze tool, which works in some occasions, doesn't work with the others. Again, you can see if it introduces too many artifacts or not around the edges of your landscape. In this case, setting it to 40. I wouldn't go beyond 50 ever, but that's in this case 40 is okay. So it makes the sky pop a little, aurora show up a bit more, and it's applying it to this part of the image and then gradually reducing the effect and stops there without changing the look of my foreground. Then the other thing you might want to do is add another graduated filter, now with the green at the bottom, green bar at the bottom, applying the changes to your foreground. Sorry, let me just delete that. Start again, about there. And reset the settings. And lift the shadows a little bit to make it more visible. So thereabouts, it's just a rough guide. You sort of know, you'll know what you want it to look like. So there is no hard rules. There is different lighting. There is light pollution that can light up your landscape. There are places where absolutely dark, where you have to work a lot harder on the foreground and do noise reduction. We don't have time for that part in this presentation, but there are temporal noise reduction tools that allow you to boost that signal to noise ratio. What you'd also want to do is do a lens corrections to get rid of the vignetting in the corners. This lens doesn't vignette much, but some others do, and lens correction settings. Where are they? It's slightly different interface in the 2020 version, so it's all kind of sideways instead of being on the top. So yep, it's in the optics. You would take vignette to sort of open up the corners a little to make it uniform, like applying an artificial flat. And then in the detail tab, make sure that sharpening is set to 0. There is no reason to sharpen Nightscapes. It doesn't do anything. So let's see what you would achieve by sharpening. If you sharpen, all you do is you just make the star profiles uglier and exacerbate noise in the foreground. So I always put sharpening to 0. And in this case, we want to apply some noise reduction when opening the raw file. Say about there, looks right. Doesn't destroy the sky and doesn't, so let's compare it. Yep, doesn't kill the sky and still produces pleasing foreground. So around 30 in this case. So I'm happy with how this file looks like. Let's fit it into the view. And now I want to take those settings that I've done and apply them to all of the other files. So I'll go select all, magnify, select all images, then right click on my image that I've done and sync settings. Say that I want to check all of the settings. So it'll take all of the adjustments that I've done, basic adjustments, curve adjustment, detail, sharpening and noise reduction, optical corrections, and click on OK. And that will apply all of those settings to all of my files. So now we Windows Escape, look at all of them, and they all look the same. Check a few across the board that it's looking the way you want it to look. So suddenly that aurora is a bit more visible. So not overly processed, but showing what's there. And what we should do now is again select all images and click on this button. Let me do magnifier. Click there, which will open the save window. Then you would select a folder where you want to save it. The format and extension being JPEG at maximum quality. So now it is okay to convert it to JPEG. You applied noise reduction on a computer that has much better compute power than your camera. You've applied differential curves, differential gradient adjustments. You've recovered data from the shadows. You protected the highlights from blowing out, and it's all you extracted as much information as you wanted from the files, or as you could in some cases from the files that you have. And then you click on the save button, and it will progressively save those files. So let's do just a new folder. Test. Select. Click save, and it'll start saving. You can see here at the bottom it says 197 remaining. Clicking on the link will open a status window showing you what's happening. I'll stop it. I've already saved those files. So let's now go to the folder where these files are saved in JPEG. And so they're there. What we should do now is switch to Photoshop and open it. So let's rehash what we've done here in this slideshow. So you select all of the images, open them in Camera Raw. In Camera Raw, you process those images to your liking. You change white balance. You apply lens corrections and correct for vignetting or curvature of the lens. You do basic corrections for exposure and contrast and saturation for the all image. Then you do gradient adjustments to treat the sky and the foreground differently if you want to. Then you synchronize all of the settings, and then you save the images. The buttons look slightly different in the new version, but the process is exactly the same. And then you bring it into a time-lapse editor. And because we're sticking with Adobe Photoshop, let's go and do that. So what you do in Adobe Photoshop, you open the image, the folder, and then you say this is an image sequence. There is a checkbox just underneath the file name. So let's go and do that.
Alex, while it's doing that, can you tell me how much computing power this all takes?
The more the better, the faster. This is running on a Lenovo P1 laptop, i7 9th generation, 32 gig of RAM, and a graphics card. So it needs a bit of grunt. If your computer is not all that powerful, then you'll just wait longer, but it'll still work. In this Photoshop, it'll work with all the hardware as well. The best thing you can do for it is get a it's more about compute power in your CPU, in your processor, rather than the graphics card. Graphics card accelerators work in Adobe Premiere, but not much in Photoshop. So the best investment is number of cores in your computer, and the faster core, the better. So look, let's go JPEG, select the first file, and then tick the box that says this is an image sequence, and do open. And when you do open, it pops up the window which asks you about the frame rate. PAL is 25. You can do 29.97 for NTSC. Then you need 29.97 frames to make a second of video. So I usually work with 25 frames a second. For internet sharing, it makes no difference. It's NTSC or PAL. Anything lower than that and then becomes jerky, lower than 25, 24. So we click OK. This opens Photoshop window. And what you need to do is go and switch it into a motion workspace. So it's window, workspace, motion, tick. And that will open an interface with the film strip at the bottom. So that's your time lapse going there. Because you are in Photoshop, you can do additional stuff to it. So you've done your pre-processing in Adobe Camera Raw, saved those JPEG images. You can still apply certain adjustments here. So for example, adjusting the white balance further, you could do that by going into Windows Plus, into Filter, Camera Raw Filter, and it takes you back to that familiar interface. You look at it and you think, oh, well, it could probably do with some more color boost. So let's give it +10 in saturation. And I want to adjust exposure slightly and say darken my foreground and brighten my highlights. And then you click OK. That applies a layer to your video layer. Sorry, adjustment to your video layer. And then what you need to do is you need to crop it. you need to crop. So you've got your 3:2 aspect ratio. When uploading the images to YouTube, the expectation is for the images to be 16:9 without those black bars. So you change your resolution to 3840 by 2160 for 4K on 1920 by 1080. And then with the crop tool, you just apply the crop to the part of the frame that you want to include. And at this point, I'd like to mention that when your primary output is time-lapse and you're setting up to shoot, you're looking at the images when you're framing and setting up your camera. Bear in mind that you will have to remove part of the image for 16:9 conversion. So you can shoot like this, or you could shoot like this, or so include discarding the top, discarding the bottom, or discarding both top and bottom. What I tend to do from purely practical reasons, I always set up to discard the top. Reason for it is that optical aberrations of the lens are not all that visible on the landscape, but if you go and zoom in, you will see those stars. Control plus. So if we go to the corner, this is a pretty good lens. So the stars in the corners look really decent. It doesn't really matter. Still, you can see some aberrations that are not present in the middle part. So that's a very, very tiny bit of coma. So if your lens is not that great, it makes sense to include the bottom part of the frame and discard the worst part of the frame optically. So we're happy with this. So what we want to show in this image, there is a bit of aurora that's happening down here. What's happening up at the top of the sky is not really all that interesting or great. There is nothing of interest much. So we'll set it. When I framed it, I had this exactly in mind, and discarding the top part of the frame. So then you double click to crop it. And you say, I want to render this video. And to do that, you go to this obscure button here. I'm sure it's accessible from menus, but I always go there at the bottom left corner, render video, name your file, select the resolution 4K preset. For YouTube, there would be a different preset. Format H.264, that's what I render for. It's usually MP4, the standard format that YouTube and all of the social media understands. And click render, and it will start doing just that, exporting video. So you can tell by looking at this progress bar, it's going to take a while. Maybe a minute or two, but I've got that pre-rendered. I've got that uploaded to YouTube. So let me cancel this and go stop presenting the screen. Go back to my video, and that render is here, full screen and cast. So that should now be casting in full screen. I don't know if it's playing smoothly or not, but that's the render of the time lapse. There, let's go back to it. A bit of aurora happening, waves moving. So a basic time lapse that is really, really quick to do. In Photoshop, the key is, so let's go back to the presentation and go to that tab, present.
We have a couple of questions in the chat. I'm gonna take a second to answer some questions.
Yep. Yes, 1 second. Let me just get back to presenting Chrome tab. This, yep. So just I'll quickly rehash what what
Okay.
we did in Photoshop. So open the image, make sure it's an image sequence, then open, set the frame rate, set the workspace to motion, crop, and when you set up, keep in mind that you will be cropping. Apply your final adjustments through all of the tools that are available in Photoshop, not just camera raw filter. It can be new saturation layers. Everything that you worked with in Photoshop is available to your video. Then click on this button at the bottom and render it as an MP4 file, upload it to YouTube, share it with friends. Okay, ready to answer questions?
Okay. So one of the questions is from Broke Astronomer. Do you have to deal with light pollution, and how do you deal with it if you do shoot in a more light polluted location?
Yes, light pollution is a problem. In Australia, we're lucky to be sort of able to travel 1 hour, 1.5 hours outside of Melbourne, and light pollution kind of stops. But what I do is I go to light pollution map, lightpollutionmap.info, and let me cast that, and just determine. I'm sure undoubtedly you would have used it. Chrome tab, share.
Linda Thomas Fowler has a related question about how dark the skies are in general when you're taking these pictures.
That depends, and you can do. So it depends on where you are. Sometimes there is a light pollution is unavoidable. So if we search for Mornington Peninsula here, Australia, that's what it looks like for light pollution now. And I usually shoot from here. From there, looking south, it looks good, and 30-second exposure is fine. Sky is largely unaffected by the light pollution. Foreground is slightly illuminated, which is helpful, and you kind of get the best of both in those blue zones if you're not shooting north, obviously, towards Melbourne. So when you scout, even if you haven't been to the location, you just look at the light pollution map, identify where light pollution sources are. So if you're shooting south, then it's okay to do from the Great Ocean Road. But if you are shooting sort of northwest, then Warrnambool will be in the way if you're too close to it, and Port Campbell. So that light pollution map is a tool that I use very often in my planning the sessions. Dealing with it is, if light pollution is unavoidable, it washes out the sky. You can't have that impact with the Milky Way. Then what I do is I either shoot in twilight hours and capture that transition from day to night, or you do it with moonlight, and then you frame differently to highlight more of the landscape than you do for the sky, and adjust the exposure even on the spot with just looking how your images turn out in the histogram and on the back of your camera.
Okay. Guillermo wants to know about, what do you do about battery power? How do you run your rigs?
Yep. So I use 12-volt batteries, usually lithium-ion cells that I buy online, and then I have a voltage converter from 12 to 7.6, or 9 volt is okay too, and just hook it up. And if the battery is strong enough, it takes me through the night or two. So that's my usual way. Or sometimes I just have a battery grip that takes 2 batteries, and that's enough in summer. But most of the time is I would use an external 12-volt power source, a voltage converter, a fake battery that plugs into the camera, and that takes care of it.
Okay.
A question from an Anik Chan. With most DSLRs being a lot higher than like the 1080 or 4K or even 8K that you might upload to YouTube, is it worthwhile to downscale your individual images when you take them to speed up processing?
I always process in full resolution and then output to 4K. Let's say if you look at Sony A7S, a 12 megapixel camera, and that's the go-to camera of choice for me for low light, because the photo sites are large and sensitive. The resolution is just above 4K. So it's if you're shooting with a higher resolution camera such as Nikon D850, I would still run that downsampling as the last step when you render, rather than, or maybe as you output it from Adobe Camera Raw. If your compute power is not great, then there is an option in that save window to resize it to 1920 by one side, and then it makes it quicker to render in Photoshop. But you would spend that time resizing it in Bridge.
Jeff was asking about your panning effect.
Yeah, for panning, I use my Vixen Polari most often, which is the astronomical tracker, tracks at sidereal rate. You can also set it to track at twice the sidereal rate, and I think now at half as well. Skywatcher, Star Adventurer, and the like would do the same. So instead of polar aligning it, you just put it on the tripod like that, pointing up, and let it go in the direction of the sky, and pan your camera slowly. Any faster than that is usually not easy to look at in time-lapse. So I usually pan at sidereal rate using just a Star Adventurer or Polari.
It looked like you were on a track in one of the videos.
I do use a track, the sliding tracker. Don't use it very often, only when I need to show something in the foreground. And I've been doing lately quite a bit of shooting for customers, CSIRO being one of them, Commonwealth Science Industrial Research Organization that maintain the radio telescopes in Western Australia. So when shooting those antennas that are stuck in the ground, little ones, then I would run a camera across them. And there are a number of tools that do it. The best one that I came across is the company from New Zealand called SERP. So they make tracks and dollies and controllers for them. So yes, it is possible. I don't usually, so kind of it depends on your style, right? If you're shooting in Bryce Canyon and you want to highlight those little features on the rock and you want to show more of them, then a dolly there, a sliding track, is a very useful tool. If you're shooting an open ocean, then if you slide 1.5 meters and your subject is 3 kilometers away, that won't make any difference. And my preference is for the latter, for the open scene, rather than something in the immediate foreground. So it depends on the subject.
There was a question about Mac. I assume all this can be done just as easily on a Mac as a PC?
Indeed. Yes, the reason I picked Adobe Suite for this show and tell is because it's cross-platform. It's available for both Mac and PC.
Do you use any time-lapse software? I know phones nowadays have time-lapse software in them.
No.
OBG70 in particular wanted to know about LRT. I think it was time-lapse.
Lightroom time-lapse. I don't use Lightroom. I use Premiere Pro for my time-lapse work and Adobe After Effects. Doing it in Photoshop is just accessible to everyone. So that's the kind of the easiest way. Then the step above would be, let me bring this slide here. This. So Adobe Premiere Pro, PC and Mac on subscription, Final Cut Pro on Mac, Adobe Photoshop, that's what we did. Sony Vegas Movie Studio, available for PC, really simple, nice video editor. Premiere Elements on the same level as Vegas Movie Studio. And then there is DaVinci Resolve, they've got free version, and Media Composer First. I haven't got a lot of experience, but that Blackmagic design DaVinci Resolve for PC and Mac looks a really, really powerful suite as well. So once you done it with the Photoshop doesn't allow you, for example, to lay music over. It's not a non-linear editor. Yes, it will make your time-lapse sequence, but it's kind of limited in what you can do. Then you step up to Premiere Pro, Final Cut Pro, or give a go to Media Composer First or DaVinci Resolve from Blackmagic.
Can you tell us a little bit more about the Ephemeris planner?
For the Ephemeris, you can go to it. It's app.photoephemeris.com.
Okay.
And I can take you through it live, I guess. But pretty much you select your spot on the Google Maps, and then let me open it. It's in one of those slides here. There, yep. So that's the interface of the Photo Ephemeris, and you can search for a place on the map, then turn the Google satellite image, and slide the slider to go to a specific time and date, and those lines on the screen will move. One is the path of the moon, the other one is the path of the sun. Quite intuitive to use.
It's one of those things where Jeff really should just kind of call it up and start messing around with it.
Yeah. So load it up, app.photoephemeris.com, and just take it for a spin. It doesn't have a steep learning curve. It's really easy to use.
By the way, your quotes on the prices for things, were they in Australian dollars?
Yes.
And what's the exchange rate right now?
Well, now it's something like 0.7 US for 1 Australian.
Do you use, Anak wants to know if you use soft filters to have the Akira Fuji effect.
Yes, I do. I do. They are, I use Kokin 840. So it's, I should stop sharing so you can, or can you switch to my camera view? I just show it.
I've got you as a small box with your face down in the corner.
Let me stop the presentation.
Okay.
Yep. So that's the filter in the case. Kokin X Pro X840. So it looks like this. It's a kind of like a frosted glass, a little bit matted glass. It's plastic, so it won't break if it falls. And what I do is I have it in front of the camera. If you shoot time lapse, you have to mount it. But if you shoot stills, what it helps is if you do this, just sort of move it to smooth it out. There are other filters, I think I can look it up, that work with it. X840 is a bit too strong, so it only really works with ultra wide lenses with 14 millimeters. If you are on the 35 mil, it'll just blow them a bit too much.
Okay.
Yep.
Folks, I think we ought to get our last questions in. If you've got any more questions, please put them in over there on the comments. I want to take you over for a second over into, where's my share my screen? Present now. Take you back to our website here. There's some things here, the contact. Remember, this is the way to get us information. If you would like to do a presentation, Thomas Fowler, for instance, recently contacted us through this and said she wants to do a show in September, um, um, about getting narrowband imaging. I think, if I remember correctly, I'll show you in a second here. And this is how we survive. I mean, we get people. We work really hard to get the best presenters we can, but remember that you're all very capable imagers. I think, remember that show that we started with to this evening, where we showed Comet Neowise for to everybody? That's the kind of imaging that's going on from you guys watching the Astro Imaging channel. So please, you've got a lot of talent out there and you should be sharing it with people. And if you go to our contact page, you can get a hold of us and volunteer to be a presenter. And we've been doing really well. This week, we've got Alex coming in, and obviously he knows what he's talking about, did a great presentation for us. Matt's going to tell us next week about how we created a 200 panel mosaic. And Mike's coming in the week after that to tell us about EAA. And then something that I'm really proud of in a lot of ways, Stella, Ellie, Linda, and Carrie Ann will be coming in over the next 4 weeks. We got 4 weeks in a row with women presenters. Now, if we could get some under 30 presenters, and we could get some, we really want to have a lot of different people presenting. We want everybody on the planet helping us with this kind of thing, not just old guy farts. We want everybody to come on up and help be part of this astro imaging thing. So we've got 4 women in a row making a presentation, and we've got others coming up in the future. So we're doing well on getting you the presenters, but we need more help getting presenters. With that in mind, if we go back over here, we've got the comments over here. We've got the places where you can donate money to help us pay for the website and things like that. Most important to us, if you have not yet subscribed to the Astro Imaging channel, hit the subscribe button so that you can subscribe to the Astro Imaging channel. Hit the like buttons to say that you like the show. It does help the demographics a lot. So, Eric, Molly, Tolga, we been monitoring? Have there been new questions coming in or anything that we haven't answered yet?
No, just a lot of comments on what a great presentation we had tonight, Alex.
Okay.
Thanks.
Thank you. I'm going to
Thank you guys for inviting me.
Well, it was our pleasure. We'll have another great show coming up next week, and we hope that you share this with other people. We will be putting that Comet Neowise show up on as a separate YouTube at some point. And
yeah, I'll get that uploaded pretty much once we're done streaming here.
Okay. It should be noted that we actually ended that before its time.
Yeah, I missed that one. That was my bad.
I think it had 30 seconds or something to go yet. So, or 40 seconds. And by the way, everybody got in there. If your picture didn't get in there, it was because we goofed when we were making it up. It was not our intention to cut anybody out. So, please, maybe we'll take advantage of that YouTube or that Facebook group page and ask you to, get a theme going again sometime in a couple of months. So we'll put together another show just like that. At any rate, I think we're finished for the night. So I want to thank Alex for being here. Excuse me. I want to thank Alex for being here. A great show. I love Nightscapes, and I think you did a great job on it. So if we're ready, Molly, take us out.
All righty.